So let us practice one more question on viscosity. That would be the last question. I would be discussing it over here. So let us say that there are two concentric cylinders. Concentric means they are having same center. Sorry for the figure, but this writing tool helps me a lot. And they are of some lengths. So how are we getting it is this. So if you watch it from the top, this is your top view, and this, if you watch it from the side, this is your side view. I can break this also, like this is a broken line because it's inside, so I can make it like this. So this is a concentric cylinder, and if I say that the cylinder, the inner cylinder is having a radius of say 5 mm, and the outer cylinder is having a radius of 8 mm. The length of the cylinder is say 1.5 meter, and the gap between the cylinder is filled with a viscosity liquid with viscosity of say 2 Newton second per meter square. This liquid is filled in this gap. I am being asked that what would be the torque required to move the outer cylinder if inner cylinder remains at rest and outer cylinder has to move at a velocity of say 3 meter per second. So outer cylinder has to move at a velocity of 3 meter per second and inner cylinder has to move at a velocity of 0. So what would be the torque required? So what I have to do is I have to just find, so let's get back to the basics of mechanics. What I know about torque is equal to F cross D. So I have to find the force and what is the distance. So force is actually shear stress into area, and the distance from which it is acting is 8 mm, right? We can easily find shear stress. So shear stress is actually mu du upon dy. So value of mu is 2, du is, what is du? It is 3 minus 0, the distance between the plates. Now the distance is 8 minus 5 into 10 raised to minus 3. Hope you're clear with it. This distance is 8 and this distance 5. The remaining distance is 8 minus 5. So this is 8 minus 5 into 10 raised to minus 3. You can have tau. So this will be 6 divided by 3. 2 into 10 raised to 3 Newton per meter square. What is the area? Now for area, this is, we'll be using the curved surface area of the cylinder, that is 2 pi r into h. 2 into pi into radius is 8 into 10 raised to minus 3. Please be very clear, every unit is to be kept in aside, and height is 1.5. So this comes out to be 75 into 10 raised to minus 3. Hence the force will be tau into area, which will be equal to 2 into 10 raised to 3 into 75 into 10 raised to minus 3. There is some value of 75. I'm not considering it for the simplicity. So this will be 150 Newton. Torque is equal to force cross distance. So force is 150 into, what is the distance? It is 8 mm. 8 into 10 raised to minus 3. 150 into 8 divided by 1000. So this is 1.2 Newton meter of torque is required to rotate the outer cylinder at a velocity of 3 meter per second. Now, what kind of questions do you see in GATE? What GATE asks is, let's copy the same system, same setup. Okay, let me try it again. So GATE will ask you that so these are two concentric cylinders. The inner cylinder is rotating at a RPM of say 450 in this direction, and the outer cylinder is rotating at an RPM of say 700 RPM, and the distance, say the diameter over here is say 10 mm and the outer diameter goes say 20 mm. Total outer diameter. I'm not considering the width only. I'm considering the total outer diameter. Let me mark it from other color. So this is 20 mm. Now I'm being asked that if this system is filled with a viscosity of 3 Newton second per meter square liquid, what would be the torque required to move the outer cylinder, right? So what would be the torque required to move the outer cylinder? What can we do? We know all the basic concept that torque is equal to force into distance and everything. But what we are stuck over here that these two cylinders are not stationary and they're moving in the opposite direction. As simple as that. What can be done? We use the concept of relative velocity. So when we use the concept of relative velocity, what modifications will be done is, so if this inner cylinder was moving at the speed of 450 rpm, I put it at 0 rpm. 0 rpm. And this 700 rpm is moving in the opposite direction, so this 450 gets added over there. So this outer cylinder moves with a speed of 700 plus 450, that is 1150 rpm. So this outer cylinder, now we have got back to our situation when one plate is fixed and another plate is moving. We have simplified that part, but we are still missing on understanding what the rpm is. So I would mark it again. The inner cylinder is of diameter 10 mm and the outer cylinder is of diameter 20 mm. So let me clarify you what rpm means. rpm is defined as rotation per minute. So if I say that I have some circle of radius r and there is an insect standing at one point, and in 1 minute it completes one rotation. So I would say that one rotation in 1 minute. So I would say this is 1 rpm. If this insect is covering 5 rotation in 1 minute, so I would say this is coming at a speed of 5 rpm. So this is a rotational speed. Now how to convert it to the linear speed? So let me take an example that this system is moving at a speed of n rpm. This insect is moving at a speed of n rpm. So n rpm means it is taking n rotations in 1 minute. So means n rotations in 1 into 60 seconds. Now rotation. What would be the length covered in one rotation? It would be the circumference. So one rotation is actually 2 pi r and the distance, the number of rotations are n rotations in 60 seconds. So what is the distance covered? Distance covered is n into 2 pi r. The time taken is 60 seconds. So the velocity which will be moving is n into 2 pi r divided by 60. Usually the rpm speed is given in capital N and I can convert 2r into d, so I can write is pi dn upon 60. Very clear? Very clear that how have we converted this rotational velocity into the linear velocity. Getting back to the question, what we have provided is that the outer cylinder is moving at a velocity of 1150 rpm. So can I get the linear velocity? Yes, I can. This is pi. Diameter of the outer cylinder was 20 into 10 raised to power minus 3 meter. It was 20 mm, so 20 into 10 raised to power minus 3 meter. And n is 1150 divided by 60. So the velocity comes out to be 1.81 meter per second. So now you have velocity, you have distance, and hence you can solve everything out of it. If you want, you can solve it and mail it to the official mail ID. I will check it and revert back to you.